Hey everyone, and welcome. Today, we are diving into a super cool project that solves a problem I think we've all faced. How do you automate something as subjective as reviewing images? We're going to break down how to build a practical AI agent that can score images based on your own custom rules. So picture this. You've got a folder with, 10,000 images. Maybe it's user-generated content, maybe it's stuff for a new campaign, and you have to check every single one. Does it fit the brand? Is the quality good? Seriously, where do you even begin? Right? It's a total nightmare. Doing this by hand takes forever. It costs a ton of money in people hours. And let's be honest, the results are all over the place. What one person calls a 7 out of 10 for vibrancy, someone else will call a 5. There has to be a better way. And here's our game plan for digging into that better way. We'll start by really nailing down the problem with manual review. Then we'll introduce our AI solution. After that, we'll pop the hood and see how it works, lay out a roadmap for you to build your own, and wrap up with some real-world challenges to keep in mind. Okay, so let's start right there with the core issue. Trying to apply these fuzzy, qualitative rules like brand compliance to thousands of images is a classic scaling problem. Humans are just naturally inconsistent, and that makes this whole process incredibly difficult and expensive to scale up. And this is where our hero enters the picture, the AI scoring agent. Now, this isn't some giant, complicated system. It's actually a pretty simple script that uses a powerful multimodal AI model, in this case, Gemini Pro Vision, to finally bring some automation and, more importantly, consistency to that chaos. And here's what makes this agent such a game changer. It takes your rules, written in just plain English, and applies them directly to the images. It can chew through an entire folder of them in one go, and, this is the best part, it spits out clean, structured JSON data that you can actually use for other things. So, the big question is, how does this thing actually work? Let's get under the hood, take a look at the architecture, and really trace the journey of a single image as it goes through the system. You know, the code here is actually really clean and smart. It uses a couple of classic design patterns. First up is separation of concerns. You've got one script, main.py, that just worries about what to do, like which files to process, and another, imagescore.py, that handles how to do it, all the AI scoring logic. It also uses something called the facade pattern, where this image score class gives you one simple function to call, and it hides all the messy API stuff behind the scenes. It's really elegant. And the data flow itself is beautifully straightforward. It all kicks off when you run the script. A library called Pillow loads up an image. That image then gets combined with your text rules to build a special kind of prompt. That whole package gets sent to the AI, which sends back a nice structured JSON response. The script just grabs that response, pulls out the data, and boom, you've got your score. Now, I mentioned a special prompt. This is the secret sauce to the whole operation. It's a multimodal prompt. See, older models could only handle text, but these new vision models, they can understand a prompt that includes both your text instructions and the actual image data, all mixed together in a single request. And the difference this makes is just huge. A text-only prompt is like asking someone, hey, score this painting for beauty, but you don't actually let them see the painting. It's useless, right? A multimodal prompt is like handing them the scorecard and the painting at the exact same time. The AI can literally see what you're asking it to score. And check this out, this is what it looks like in the actual Python code. It's not some crazy complex thing, it's just a list. You have some text, you have your custom rules, you have a command telling it to return JSON, and then you just drop the image object right in there with everything else. That's it, it's that simple. Okay, so we've seen how it works, the theory is done, now let's talk about how you can actually build this. We're going to walk through the exact steps and the tools you'll need to get your very own image scoring agent up and running. And the great news is, you don't need a whole lot to get started. All you really need is Python 3, the official Google AI SDK to talk to the Gemini model, and the Pillow library, which is fantastic for handling images. That's your entire toolkit. So here's your step-by-step roadmap. First, you set up the project, install those dependencies. Then, you write a little function to load images. Next up is the core logic, building that multimodal prompts and making the API call. Once you get a response back, you parse the JSON. And finally, you tie it all together in your main script. It's a really clear path from A to Z. All right, before you run off and try to build this for a huge production system, we need to have a quick reality check. Because like any new, powerful technology, there are definitely some challenges and things you need to think about. So first off, the AI won't always return perfect JSON. Sometimes it messes up. Your code needs some solid error handling for that. Second, remember these scores are qualitative. They're consistent, but they're not objective truth. Third, API calls cost money, and that can add up fast at scale, so you've got to manage costs. And finally, you might need to resize really large images before you send them off. But when you step back, what this all really proves is that we now have this incredible tool for bringing scale and consistency to these messy, subjective tasks. Yeah, we've applied it to scoring images, but that's really just scratching the surface. It leaves us with a much bigger question to think about. What other slow, expensive, subjective human jobs are finally ready to be automated?